Hey, geometry. Going to talk to you about similar triangles today. We're going to start by reviewing what similar triangles have going for them. Two triangles that are similar, all angles are congruent. And all sides are proportional. But we have a few shortcuts that we can use. On the back of these notes, we've got the three similarity shortcuts. We've got AA, which stands for angle, angle, SSS, which stands for side, 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 and SAS, which stands for side, angle, side. AA similarity says if two corresponding angles are congruent, then the triangles are similar. So let's go down to example 1. The first thing I'm going to do is solve for angle C in the big triangle. I'm going to subtract 74 and 75 from 180, and I get 31 left over. So angle C is 31 degrees. From there, I'm going to match up the 75-degree angles and then the 31-degree angles. Each of those counts as an A in our book for similarity. So I have AA represented in both triangles, which means that yes, they are similar because of AA. In example 2, the triangles are also going to be congruent by AA. Let's see why. In the middle of this picture around capital X, we have vertical angles. So not only do the angles with one curve match up, but the angles around X, the vertical angles, match up. Again, that counts as AA in our book for similarity. And that's good enough to say that they're similar. The next kind of similarity is SSS, and this says that if all corresponding sides are proportional, then the triangles are similar. So, what I'm going to do for number 3 is make some little over big fractions. So the sides from the little triangle would be 3, 4, and 5. Notice I went least to greatest. And then the sides from the big triangle would be 6, 8, 10. Notice once again I went least to greatest. Now let me reduce each of these. 3 6, 4 8, and 5 10 all reduce to 1/2. Since they all reduce to 1/2, that counts as 3 S's. If they reduced to different fractions, those would not count as S's. So let's see what happens here in number 4. I'm going to do little over big again. The sides from the little, least to greatest, 24, 25, 28. The sides from the big, 30, 32, 35. Now I'm going to reduce (24/30) would be 4/5. 25 over 32, unfortunately, does not reduce. 28 over 35 is also 4/5. But since 25 over 32 does not reduce, it does not count as an S. Therefore, we only have two S's, which is not good enough. So these triangles are not similar. The last kind of similarity is SAS. This says if two corresponding sides are proportional and the included angles are congruent, then the triangles are similar. So, we are first going to notice that the triangles in example 5 have matching angles. Then we're going to set up little over big fractions, and that would be 6 and 15 from the little, and it would be 8 and 20 from the big. Both of these are going to reduce to 3/4. So that counts as two S's. And the angle that we highlighted at the beginning counts as the A. And that's how we get SAS. Another common example of SAS similarity is number 6. Remember I said that we look for the matching angle first. The matching angle is going to be in corner A. That angle is shared by both triangles pictured here. The first triangle pictured is the triangle ADE, and the second triangle pictured is triangle ABC. So you see both of them have that shared angle, angle A. So we know where the A is located, so now we're going to do a little over big. Sides of the little are 12 and 15. Sides of the big are 21 and 25. One of them reduces to 4/7, and the other one reduces to 3/5. Unfortunately, since these do not equal each other, we do not get any S's out of this. So, once again, this is not good enough for SAS. These triangles are not similar.